Welcome to the Discover Mathematics series. In this video, we're going to see how one can use tiles to approximate square roots. Okay, let us look at this example where we can see that the length of the side of the square is 5 and the area is 25 centimeters squared. So each length is 5. This is 5 centimeters, and then the total area is 25 centimeters squared. So the question is, what is the length of the side of the square whose area is, in this case, 25 centimeters squared? Now what we can see is, well, the answer is going to be 5. But another way of writing the question is, instead of writing this question, this whole long question, I can simply write the square root of 25 is, in this case, the answer is 5. So this question of the square root of 25 is the same as, it's the shortcut way of writing what is the length of the side of a square whose area is 25 centimeters squared. The shortcut is using that square root symbol. Okay, now we're going to look at an example when it doesn't make a square. Here I have 12 tiles, and I want to make squares. But I realized that with the 12 tiles, using all 12 tiles, I can't make a square. So my question is, what is the area of the square whose side is 12? Well, I don't have a square, so I'm really looking for the square root of 12. But since I can't make a perfect square using 12, what I realize is I can make a perfect square using less than 12. And if I remove these 3, then I have a perfect square whose area is 9. So that's using less than 12, so I know that 12 is more than the square root of 9. Because I had more tiles, so I removed them. So my answer for the square root of 12 is going to be more than the square root of 9. But I still don't have a perfect square, so what I'm going to do is, that's 12, and if I add some tiles, I'm going to make a perfect square that's larger than 12. And when I add more tiles, I get 16. Using 16 tiles, then I will have a perfect square. So then I know that my approximation for 12 is going to be more than three, and it's going to be less than 4, because the square root of 9 is 3, and the length of the side whose square is 16 is 4. So my approximation for the square root of 12 is going to be between 3 and 4. Okay, in this example I have 21 tiles. I formed them into a rectangle, but I can't make a square using the 21 tiles. So I want to see what is the the largest perfect square I can make using less than the 21 tiles. And when I try to use most of the tiles, what I'll see is that I can make a perfect square using 4 by 4, but I can't make one using a perfect square root of 5 by 5. So then I see that I have the square root of 21 is going to be more than the square root of 16, and with my 16 tiles, I see that the length of the side is 4. So I know that 4 is less than the square root of 21. And now I'm going to look for the smallest square I can make using more than the 21 tiles. So let me put these tiles back that I had, and that's using 20, 21, 20, I need to put them over here, 21, 22, 23, 24, 25. So I added 4 more tiles, and now I have a perfect square, and the perfect square has an area of 25, and the length of the side is 5. So I know that the square root of 21 is between 4 and 5. Okay, in this example, I'm going to approximate the square root of 24. I have 24 tiles, and I formed it into a rectangle that's 6 by 4, because I cannot make a perfect square. So since it doesn't make a perfect square, I'm going to take some of the little tiles away to see what's the largest square that I can make that's using less than the total 24 tiles. And if I take those away, it's a rectangle that's 4 by 5. And if I take these away, then I have a perfect square that's 4 by 4. So I'm using 16 tiles. So the square root is 16. The area is 16. I'm looking for the length of the side. So the length of the side is 4. So since it's smaller than the total of 24, then I know that the square root of 24 is greater than 4. And now I'm going to put these tiles that I had, I'm going to put them back on and see how many more I need to add to make a square. So these, what I'm going to do is I'm going to put these down here. And I have 5 on across the side, and I have 5 going up and down, and I'm just missing 1. So I'm going to take this yellow one and add it in there so you can see that that's what's missing. So now the square root of 25 I know is less than the square root of 25. The square root of 24 is less than the square root of 25, so this is less than 5. It also suggests that my square root of 24 is going to be much closer to 5 than it is to 4 because I'm only missing 1 tile. And so that's how we're going to be able to get an integer approximation for what any square root is, to look for the largest square less than that number, like we did here for 16, and then take the square root of that square, or the length of the side, and then look for the smallest square larger than that number, and that'll give us the length of the sides. So that will give us the integer values where the square root's going to be in between. And that completes this video. Thank you.